Sound check? Can you hear me? Yeah. OK, cool. So finally, thanks everybody. My talk tonight, it's a way to handle async in Redux. First, before starting, a little bit about myself. I'm Nick. I work at the Open Table. I'm co-author of Create Cycle App and Redux-cycles. Follow me on Twitter. I will share the link to the slide afterward. Little bit about what I'm going to talk about, a little bit structure of the point that we're going to touch. First of all, I don't know how many of you know about Cycle.js. I will do a very, very quick 101 to intro about the concept. And then I will explain, this idea about the Redux-cycles middleware, some about the rationale why we build it, some code example because talk is cheap, testing, how to do testing with it, how to structure the code with it, and some takeaways. So let's start. But before going into, I found this on the official Redux documentation. This maybe you might want to explore something like Cycle. And I think it's a great idea. So let's try to explore it. The first things, if you go to cycle.js.org, you will say that Cycle, it's a functional and reactive JavaScript framework for predictable code. Maybe at the first timer, it doesn't tell you much. So another nice way to say what it's all about, it's an interesting and unusual way to represent real-world programs. So let's see how a programs in Cycle looks like. So let's say that we have anatomy of a program. A program in Cycle is just a function, and it's a pure function. It takes in what they call sources that actually are events from the outside world, and it emits other events that's other stream of events of commands. It's say, this is what should happen in the outside world. So command to be performed. For example, let's say that we have a source of HTTP response. What we can do, we can react to that by simply using some reactive library operator. And then we can, for example, say, oh, we want to create a stream of requests to perform. And we create maybe a stream of object defining how the request should look like. At this moment in time, we are not firing any request. And then we return this stream of requests to something that it's called syncs in Cycle.js nomenclature, let's say. Mainly the key in this object that we return, it's relative to the driver. And the driver is what handle side effects. So mainly what we are doing here, HTTP driver, do this request when the stream emit. So how do we run these programs? So we import what it's the core of Cycle. It's called the run function. Then we import all the driver creator. So we can create a driver. In the case that we saw our program, we need an HTTP driver. So we import this. Our program that we saw, and then we define the driver. So it's just a key. And then we create the driver. And then we run the program, and we pass the driver. What happened in this moment in time is we are kind of starting a reactive loop. So our functions, the output of our function, is the input of the same function. So we can represent something like that. So let's say that our program emits things that are command to be performed in the outside world to the driver. The driver do this, for example, HTTP request. And when it gets response, it's feed back into our program. And so we can keep reacting to that. One thing that maybe I missed, but maybe was interesting, it's like this. Maybe you did a weird face when you saw this, because they'll say, oh, how weird. There is response before request. Yeah, that's an important point. In F&RP, it's the order of code doesn't matter. So it's that's easy for refactoring, because we can move things around. So few points about it. It's a predictable code for async, and that's because it's a pure function. It's you don't have to mock anything, and that's where the predictable in the description of the project came from. Programs are pure function. Read-write effects are done with drivers, as we saw, And as a framework, it's like, I think this is like the strongest characteristic of Cycle. It's agnostic in the sense of the type of application that we can write with it are not tied to graphical user interface. For example, when we write something with React or with Angular or with any other, we are tied to something that's like, it's tied to the DOM somehow. As we saw, we just did something that was like responding to HTTP requests. So it's like it was an application that's like didn't have within a graphical user interface. So it's like we tend to say UI instead of graphical user interface. So back to the quote from the Redux documentation. Actually, this wasn't complete. The complete quote was something like that. And they asked, and they were suggesting, well, maybe you even want to combine Cycle with Redux. And if you do, let us know how it goes. Well, we did. And long story short, how it went for us was like, it went really awesome. And it went so awesome that we decided this is like the logo of our middleware. And the name is like Redux-cycles. But so let's see how that can look like. So with a trivial example, let's say that we want to react to ping action. So like, we emit a ping action, we dispatch it, and then after that, we want to react by dispatching a pong action. Actually, what we can do is like we can filter for all the ping action coming in as a source from the outside world. We map to a pong action, and then we pass this stream of pong action to be dispatched to our action driver. And so it's like actually say, hey, driver, whenever a pong emits, dispatch that action. And so this is like a very, very simple example of how Cycle middleware work. The API for it, like we have a create Cycle middleware. So similar to everything you do with Redux, you create, store, and apply middleware. You import this from Redux library. You import the create Cycle middleware from Redux-cycles. You import run, again, from Cycle, as we saw at the beginning. We import our program. That's, for example, this Pong cycle that we just saw. And then we do the usual wiring. So it's like we instantiate the store, we passing the reducer, and we pass our Cycle middleware. When we instantiate the Cycle middleware, we also get some driver creators. Like, for example, in this case, we have make action driver that we can use to create our driver and start our Cycle reactive loop. This can look something like that in the specific example. Let's say that we have a Pong cycle program that we just saw. In this case, we will have action in, action out. So it's like we emit like commands of action to be dispatched that goes to the action driver. And whenever an action gets dispatched to Redux, we feed it back into our program. We saw it's like that there is like an action driver. But the middleware also come for a state driver, because sometimes you also want to kind of read the states, and you want to compose and react accordingly. So for example, what we can do with it is like it's a simple logger. What if you want to log the state and the action be dispatched every time? We can do that by first, we get like the action stream, and we filter for any action that is like it's not a log action. And then we compose this with the state stream. And then we debug. We use the debug operator from Xstream. This allows you to console log the state of the stream at that time. So we will have something like that in our console log. So the action, the state is like that's our string, and then the object will be the action, and the state at a value of 0 at that point. And then we can map over it and say, okay, this is like the log action that I want to dispatch. And we return, of course, this stream to the action driver. So say, okay, dispatch this log action. Another utility that comes with the middleware is like combined cycles, because we don't want to have like a whole huge function to handle everything. So we can just compose function together. Pretty simple. We import combined cycle utility from Redux-cycles. And then we can compose any number of cycle apps together. So this is like, it's a quote that I found on internet. Of course, if you follow the link, it was ironic. But I think there is a little true in the sense of how you handle async in Redux can be sometimes daunting. Like there are many opportunities, there are many options to choose from. And so it's like you might ask, why building yet another one? And it's a good question. So it's like, why yet another middleware? What we wanted to have like a way to react to our action handle async using reactive and declarative code. That was our goal. We say, okay, this is what we really want. And we look at out there, and there was something like Redux Saga that is amazing because it's like declarative, but it doesn't use the reactive paradigm. And then there was like something like Redux Observable that is reactive, but it's not declarative. And we will see a little bit about it. By the way, Redux Observable is like, it's an amazing project. It was like highly inspirational for us to build Redux-cycles. And so this is where we fit in. But let's see an example, for example, with Redux Observables. So with the Redux Observable, what we do, similarly, we filter the action, and then what we map over it. But what we are doing here, we are actually firing a request. And then when the response gets back, we map and we dispatch a new action. So this, yes, is imperative code. So we didn't want that. We wanted something that's like, was easier to test without having to mock this aspect. And so let's see the same example with Redux-cycle. It looks a little bit more code, but it's kind of interesting to read through. So what we do, we react to all the user coming in, and we map it to an action that should be dispatched. So it's like, but no action happened at this moment in time. It's just like say, oh, this is a kind of action that we would like to have. Exactly, no action is being fired here. And we pass this to the HTTP driver and say, hey, driver, whenever like we get like a fetch user action, do this request. And then on the other side, we want to react to the response. So whenever a response comes in, we want to do something. For example, fetch user fulfilled, dispatch a fetch user fulfill action. And then we pass this to action driver so it can dispatch it. Maybe a less trivial example, and it's like how to build like an autocomplete, totally in Redux. So similarly, we can like create a stream of search query by simply filtering all the search user kind of action. And then we map over and we take out the string. For example, you have an input, you are typing something, and every time you are typing, you emit an action with that string. And then, so we're mapping and we create a stream of that strings. We make sure that the strings is not empty. Nice little add-on, we can debounce it. So it's like, we make sure that if you are typing too fast, we don't fire all the requests. And another thing, it's nice, we can compose this. So if there is another action being dispatched somewhere else in your UI, for example, that you want to clear the search result, you end that stream. So that's in the action, the HTTP request does not get fired. Then we map over this search query stream, and we create what should look like as a request. And we pass this to the HTTP driver, say, hey, whenever this happens, dispatch this. Not dispatch this, fire this request. And then when a response comes in, we want to react to the response and do something with it. So for example, get the stuff out of the body of the response, and then create an action with the value in it. And then we pass it to the action driver so that he can dispatch it. The nice thing is like you can see the data flow in real time here. It's like we can use a tool, for example, the Cycle dev tools, because it's using Cycle behind the scene. We can have effect on this. You see that when it's typing, and it's typing multiple times, no HTTP request is being fired because of the debouncing. And so even, and when that happens, then only then the HTTP emit. And so it's like it's very, very easy to visualize what is happening behind the scene. That's like one of the problems with the sync. It's like Redux is very easy to reason about. To look at the flow, it's like very easy. But when you put async into the equation, it can be a little bit less trivial to understand. So how do we test those things? One nice quote about Rob Wormald, it's like they say that writing tests with marble diagram is pretty much the coolest things ever. I totally agree with him, but you probably say, what the hell are marble diagrams? They look something like that. So it's a way to represent in a string value happening over time. So every character, it's like it's some moment, like for example, 20 milliseconds. And then we can say, okay, if it's 20 milliseconds, after 60 milliseconds, the value 1 get emitted. After other 40 milliseconds, the value 2 get emitted. And after 60 milliseconds, the stream stop. And how we can use this? Well, let's imagine we want to test the function that we just did for the autocomplete. So it's like testing something like that. It's like, it can be a little bit complex because we really want to test the debouncing and everything that happened exactly the same time. So how could we do that? Well, let's imagine that we have some actions. For example, L, LU, LUC. This is like, it's the user typing. It's like the first time you type a L, it's like we emit this action with the L in it, and then LU. Okay, you got the picture. So what we want to do is like that should return something like that. We should return a stream that actually have just one request, a model of a request that contain look, that was the latest one, if we assume that's like the get typed within the debounce time. Okay, so we can put that together using a marble diagram. We can say, okay, ABC, and map this to the action source. So it's like ABC will be represented the 3 actions that we just saw. And we say, okay, we want to, we expect that what we get out, it's like it's an HTTP stream that's like have an action at the end, the one that we saw, exactly after the same amount of time corresponding to the bounce. So you can do that like also for the HTTP coming in and coming out, output and things. And another thing that is interesting is like that you see this interval 200. So let's say that we can state how much this character in the marble diagram represent. Let's say that we say 200. Mean that if our marble diagram was like 10 character, it's like 2 seconds. So testing this will be 2 seconds. Well, if you run this, actually take 15 milliseconds. And this is because behind the scene, we can use virtual time. And so it's like we are able to do this testing and making sure that the concurrency of everything is like it's totally is totally in the right order that we assume. So that's pretty awesome. Yeah, that's like. Another thing is like it's how can we structure our code when we use something like that in Redux. Probably many of you know the Redux. It's like it's from Eric Erasmus. It's like it's a nice way to structure your Redux code into something like modules that like bundle. They call the reduce bundle, and they obey some rules. So for being a module in a DAC module, it must export default a function called reducer. So it's like that's your reducer that you want to put in the model. It must also export its action creators as function. It must have action types in a specific format. We will see in the example how that looks like. And then it may export its action types as upper snake case. My suggestion is like that it may export its cycles as a single function called cycle. Let's see that in the example. So we say that it must export a default function called reducer. There it is. Then we must export its action creator as function. We must have action type in a specific format. And it's like normally it's like the name of the app or the npm, the component, and then it's like the type of action. And then we can export all the cycles related for that part of the state as a single cycle. So using combined cycle, for example, we can export this as a single one. This is super nice because at this moment, if we test this module, we are sure that everything related for changing that specific part of the state tree, together with the action needed for that changes, together with the async actions, all can be tested there. Some takeaways. So I would say that's like Redux-cycles. It's predictable code for async in Redux. That's why we really, really like it. You may want to use it if you want to write reactive and declarative code, because that's like the only solution that I'm aware of at the moment for doing that. There are no R dependency on a specific stream library. So there is like an open, we have a pull request open for that, and we are working on it. That should be happen like in the next weeks. What that means, it means that the example that I give, I was using the Extreme library. But you can use React.js, for example, or Most.js, or any other library. Why you would want to swap? But for example, it's like if size matters, like then Extreme is way lighter than Redux-JS. If performance matters, then most JS, it's way more performant than any of the others. So this is like something that it's very, very added value. For example, with the Redux observable, you have an R dependency of it on Redux-JS. But one more thing. Maybe you don't really need Redux if you already use a reactive in your code. That's also still from the official Redux documentation. Well, why? Because some say it's a two-liner, and actually it kind of is. So it's like you can see that like your store could be just a stream of actions, and then you initiate with the initial state, and then you fold or reduce over it, and using, for example, your ut reducer. And then you can simply subscribe to it. Few acknowledgements that I would like to thank. It's like Luca and Gosh, that's like they are the other core authors for the Redux-cycles middleware. JFiles for Redux observables. And Phil, that's like it did an amazing slide deck on Redux observable, and also like I think the best spectable code that I used for building this slide deck as well. So thank you, and if you got any question.
Do you have any questions for Nick? No. Oh, right at the back.
Hey, no. Oh, okay. I was just going to ask, how do you connect components to the cycles? So, is it just the actions, or I mean, when you dispatch actions from your components, how do you kind of have it linked up?
So whenever it's like you just use Redux as you normally use, and you dispatch action. And this is like, it's just a middleware for Redux. It's like when your component will dispatch an action, that will pass through the middleware chains in Redux, and they will feed into this reactive loop of cycle, and that will feed back into Redux.
Okay, cool. So
Any more questions? Oh, over here.
I'm just wondering, how big is Cycle itself? Because you will introduce Cycle and probably another library for the reactive that I don't remember.
Yeah.
So how big are they in the bundle at the end?
Yeah, good question. So the Cycle core library, the run that you saw, it's probably around 140 lines. So it's like it's not much. The stream library depends on your stream library. If you want, for example, something light, I would say go with Extreme. Extreme is probably around 20K compress compared to Redux-JS that it's way heavier. This I think is 140 or something like that, if I'm not wrong.
Any more questions? Oh, over here, yeah, brilliant.
So for side effects, do you have to write your own driver each time? So any type of side effects. So if you want to like use WebSockets or something, would you need to write your own driver for that?
Yeah, good question. So there are tons of drivers available already. So it's like WebSockets, even Firebase. There is one that I've seen recently for GAN database. So it's like there is a lot of drivers out there that you can use, but you can write your own. It's like writing a driver is not that complex. For example, the action driver that you see being used in the middleware, I think it's around 12 lines of code.
Thank you.
Thanks. Any more? Brilliant. Thanks very much, Nick, for your talk. So I previously got my Nicks mixed up. So now we've got Nicholas talking about Git and the upgrade path for React Native. So can we have a round of applause for Nicholas, please?
So, yeah. Okay. I'll just mute. Yeah. No, it wasn't. Okay.
All right. So let's have that blue background. Do you mind just leave this one on your pocket? Do you have audio in the presentation?
Sorry.
Do you have audio in your presentation?
Audio presentation?
Audio.
Oh, no.
Video.
No. Okay. Hello, everybody. Today I speak about upgrading React Native on an existing project. Let me introduce myself first. My name is Nicolas Curie. I come from Lyon in France. I'm a JavaScript developer in a consulting company named Zenica. And I work since 2 years for 6play. It's a TV channel number 6 in France. And sorry, I was specifically on the 6play platform, which is a catch-up TV and a VOD platform for the channel, just like ePlayer, I think, for the BBC. It's an awesome project, full of React, and soon React Native. So, if you work with React Native, there are pretty good chance that you have run this command before to initiate your project. It generates this structure with an Android directory containing an Android application, an iOS directory containing the iOS application. These directories contain real native apps. You can run it with Android Studio or Xcode. These apps are very tied to the React Native package inside your non-module directory. Their only job is to open a React tool view or ACT tool view, depending on the platform, full screen, which hosts your React Native bundle. These apps are generated, were generated with Yeoman. It's a pretty well-known generator in the JavaScript world. It's very simple. It just processes all the files inside the template directory, replace some placeholders, and then output the file somewhere. Yeoman has been removed, but I kept the slide because we are in London, 2 stations from the Tower of London. So, well. Yeoman has been replaced with a homemade solution because it was responsible for a quarter of the React Native package subdependencies. So they remove it to make the package lighter, faster to install. But this homemade solution works exactly the same. So I still call it the generator. Well, you initiate your project. You start to play with React Native. You're happy because it's good stuff. And the time has come, you have to upgrade React Native on your project because a new version is released. So when you upgrade React Native, you have to install the new package in your node module, and then you have to update your native apps. Because these apps, like I said, are tied to the React Native package. It uses React Native APIs. It contains references to part of this package. So if the APIs change, if the reference change, you have to update your native apps. So the changes required by the new version of React Native are embedded in the React Native package, in the new version of the generator. So you have to update your app with this new version of the generator. And how to do that? The question exists on Stack Overflow. It's a real question, I just paste the title here. How to update your app with a new version of the generator. Here is the answer by Sindrezorus himself. He said, just run the generator again, just like you did the first time. And if the output directory is not empty, Yeoman will detect that, and for each file, he will compare the existing file with the new one, and he will ask you about what to do. So that's exactly what happened when you run the React Native upgrade command. Here, for the app-delegate.m, the existing file is different from the new file, so it prompts the user and asks about what to do. I see two weaknesses here. The first one is the change detection. The change detection is very basic. It just compares the content of the new file with the existing one, and if it differs, even from a single space or empty line or whatever, the file is labeled as conflict. It's not conflict like we think about conflict in a versioning system. It should be change here, not the same, just that. And second weakness, the choice. There are two choices, overwrite or do not overwrite. So it's very basic. I mean, just overwrite all your file or do nothing. And it's generally not what you want. It's a Yeoman situation, and it became a real problem when using Yeoman, the generator, with React Native because React Native is released every month, and if you want to follow this release, and you should, my advice, you have to repeat this process again and again, and resolving the same conflict each month. So it's very boring. Secondly, conflicts generally take place in the native apps. So if you are a JavaScript developer, well, like me, the contents of the file are generally unfamiliar. It could be Java file, Groovy file, C#. I don't speak about Windows, but it's exactly the same. And of course, Objective-C. But if you are a JavaScript developer, it's hard to resolve conflict, because to resolve conflict, you have to think with your mind. You have to understand what you read to make the good choice. Even worse, the project.public-posh file, the nightmare of all iOS developer and React Native developer. This file contains all the settings of your iOS app in a single file, huge file, thousands of lines of codes, and in an obscure format. It's like JSON, but it's not JSON. Well, it's very hard to resolve conflict in a file which is not even human readable. Last point, during the lifetime of your project, you will change stuff in your native apps. And each time you change something in your native app by, I don't know, customizing assets, add permission or whatever, you increase the probability to get conflict later. So during the life of your project, upgrade become harder and harder. So let's examine the situation, the different situation you can face when upgrading. Imagine you have generated your project in React Native version X, and later React Native is released in version Y, and the content of the file hasn't changed. When you upgrade from version X to version Y, the existing file on your left is the same as the new one on the right, so Yeoman is happy, the generator is happy. Don't ask you anything, skip to the next one. Okay, that's the easy case. But if you have changed this file with new content, the existing file in the middle is different from the new one. And the generator will ask you to override or not. And it's annoying. It's annoying because the file hasn't changed between version X and version Y. So it shouldn't be concerned by the upgrade. But it is. Other case, the file has changed in the version Y. Once again, Yeoman the generator asks you for a choice, And once again, it's annoying because you never touch this file. You may not even know it exists. It may be the first time you see this file. So you are in front of your terminal and you are asked for a file you have never seen, and you are like, just override it and shut up. Don't ask me that. So it's annoying. Last situation, the file changed in version Y, and you have changed this file. This case is the real conflict case. I mean, a human decision is necessary here. The upgrade tool can't know which file to choose. So you have to do something here, and you can start to cry indeed, because the only tool you have to make this job is the diff between the existing file in the middle and the new one on the right. Here is an example of a diff of the project.pbxproj. This file is like a embedded database in a single file. Each part of your iOS app, each part of each build configuration, build phase is referenced with a hash. You can see it on the left. And you have multiple occurrences of this hash within the file. It's like IDs in a database. And you have to read this diff and pick the line you want to resolve the conflict. And if you pick a hash here, and you pick the wrong one hundreds of lines below, well, your database is corrupt. So Xcode won't start, the run iOS command will crash. Well, you perfect. You have nothing to do but reverting all your change and restart from the beginning. Okay. For those who experience the React Native upgrade, did I describe the situation well? Nightmare it is. Let's try to improve the situation. There are two problems, I think. We should be able to avoid, or at least identify, the undesirable conflicts. I mean, this situation and this one, where a human decision is not necessary. And then, in case of real conflict, this one, we should be able to know immediately where the change comes from in order to resolve the conflict. We should know for each line if it comes from change you made or your team made in your project, or if it comes from the new version of React Native. So I come with a solution which consists in isolating React Native changes. I start to work on my own, on my machine, with a blank app. I created a blank app outside my project in my current version of React Native, and then I upgraded it with the new version of React Native. And when I was asked for a choice, override or not override, I select yes, override. I don't care. I didn't change anything in it. I have nothing to lose, so overwrite the code. Then, with Git, I'm able to print all the difference between the current version and the new version. And I isolate the React Native changes. I start with that. It was useful, really. It helps. So I created the rndiff repository to make it public. Maybe you have heard of it. On this repository, I created a blank app called rndiff app in a very old version, 23, and I upgraded version after version, one by one, to the recent one. And thanks to the GitHub compare views, I'm able to see a compare view between two branches. Oh, I forgot to say, I created a branch per version. So if you get there, here is an example of, so it's pretty old version, it's the 28 to 29, and I have all the changes required by React Native from 28 to 29. Before that, we wasn't able to do that, to have this information. So in version 29, so some changes, flow config, a split with a React main activity and main application, well, something. So you can see all the React Native changes in it. So it helps because you are able to identify the undesirable conflicts, like I said. If you upgrade React Native and you are asked for overriding or not a file, if this file doesn't appear in the rndif, it means that it's not concerned by the upgrade. So you can skip it immediately without bad effect. In case of real conflict, it helps to, the rndif diff help to take the good decision if you want to override your file or not. What I mean by good decision, it's the less painful option. The option will require the less manual changes afterward. So if you choose to override the file, you probably have to report your changes in this file. And if you do not override the file, you probably have to import the React Native changes. So at this moment, a colleague of mine told me, okay, what you did is great, it's helpful, but it's still manual operation. You put everything in Git, it's cool. Why don't you use Git patch to apply the changes automatically? So I was like, yes, of course. How I didn't think of that. Yeah, we should do that. So I tried to generate a Git patch from rndif. It's very easy because if you append .diff to the compare view in GitHub, you get a real patch. You could demo that. Yeah, that's a valid Git patch. Very easy, but I can't apply it easily because there are some problems. First, cycle, the blob here, the blob entry here is an identifier of the version of the file in the rndif repository. And if you want to apply this patch on your local repository, this blob need to be known by your local repository. So you had to fetch the rndif repository. And this patch has been generated for the blank app, so there are occurrence of the name of the blank app everywhere in code, so you have to replace all. It's not so easy. It's a bit hacky, but it works. It works. I did it sometimes. It works. In the same time, Christopher Shadow on Reactive Flux declares that he was interested by React Native, by rndif, and this approach should be the official process. Sorry. I was pretty happy to hear that, really. Cool, but this process is kind of dirty. If it becomes an official process, we need to find something more reliable, cleaner than that. So instead of using a patch from rndif, we should be able to generate a patch from our repository using the generator. We need this free version of each file. The first one is your current sources. So it's very easy to get. Just do nothing, you have it. The second one is the file directly generated from the template in your current version of React Native. So to get this, you have to run the upgrade command without upgrading React Native in the current version and answer yes every time you ask for overriding. The last one is the same, but in the new version. So install a new React Native package and then run the upgrade command and override. Once we have these three files, we should be able to generate a patch. So let's do this. I have a demo application here. It's a React Native application. It's in version 30. And I'll try to upgrade it in version 36. So my working copy is clean. I run the React Native upgrade in order to have my second file, React Native upgrade. Okay, so I answer yes, yes, yes again, yes again. I don't read the diff, I don't care. I just want the pristine version of my file. Okay, I commit it. Git commit, commit message, all version, I mean current. Then I have to upgrade React Native. So it will be very fast, thanks to Yarn. I didn't choose a recent version because the three last versions of React Native bring a lot of changes. So I wouldn't have been able to do a demo in a few minutes. Okay, then React Native 36 is installed, so I can run React Native upgrade again. Yes, yes. Okay, commit. New version. Now I'm able to generate the patch. So it's a diff between the previous commit and this one. So git diff head -1 to head. Here is the changes required by React Native in my new version. I have some changes in my flow config, some changes in the project.pbxproj, info.plist, and that's all. Okay, it's not very helpful. I have to save it on the file system. So up, git patch, update.patch. Okay, so now I have two commits, old version and new version. I use it to generate the patch, but now they are useless. I will delete them. So git reset minus hard head -2, reset 2 commits. Okay, I'm back to my initial state. I just have the patch file. So I'm able to run git apply -freeway and the name of the file. Okay. Okay. So the output is not very friendly. Error, patch fail with conflict. The error code is the exit code is 1. So yeah, but it works. The patch has been applied. If I run status, I can see 4 modified files and my project.paybackspoj in conflict. So I just print the diff without any argument. So it's a diff of my, this is why my working copy is not clean. So I can see in the project.paybackspoj that a lot of change has been reported in it here. And you can see here conflict delimiters. This is the only place where the upgrader can know which line to choose, because I modified it and the new version of React Native changed it too. So I have to resolve the conflict. And it's a real Git conflict that you are used to resolve if you use Git. You can think of the label here, ours, as our team, my team, me, and theirs as the React Native team. So in that case, if you remove the conflict delimiter, this free line, it seems that you are good to go. Few lines below, I have another conflict. And once again, this comes from me. And when I read this, I remember that I have had the OK app SDK. Well, OK, that's my changes. I need it. And the React Native version required this line. So once again, I can remove the conflict delimiter, and I'm good to go. It's often the case, not always, be careful. Sometimes if you do that, you can have a syntax error. So you have to be careful about when you resolve conflict. But it's far easier than before when you have to read thousands of lines of code in your project.paybackspoj. OK, I didn't mention the other file. The other file have been merged automatically, so you don't even care about them. Well, I have implemented it in the React Native repository as a new tool, upgrader tool. All this operation is, it implements this exact operation automated with Shell.js, but it's really the same principle. The difference is that he used Git local repository. Don't use users repository because we want this tool non-intrusive, you know. So it creates a repository in a temporary directory. But it works exactly the same. You can use it. It has been published as an external package for now, because I really wanted this tool to be available to anybody, whether the React Native version. So that's why it's a separate package, and it's not embedded in the React Native package like other stuff. OK, that's all I've got. Thank you for your attention. Any question?
Okay, you got scot-free. Oh, thanks again, Nicholas. Cheers. You take a 5-minute break to grab another beer, go to the loo, whatever. So yeah, 5 minutes sharp, please. Thanks. Ready? Welcome back. Welcome back. So, as promised, we have Alex and I've forgotten your name, Rob from the BBC, who are going to be talking to us about draft.js and using it for more multimedia things. That's great. So, without further ado, I'll hand over to them. Thanks.
Hello, thank you for bearing with us. Broadcasting company. I'm Alex, this is Rob. We both work at BBC News Labs as developers. What is BBC News Labs? We're a team in BBC. We sit in between BBC News editorial, which is journalists who write articles, do video on the website, and produce videos that you see on TV. News product, who develop the website and the app, and lots of kind of behind-the-scenes systems and infrastructure to distribute our content. And BBC Research and Development, who are kind of proper, like, serious socks and sandals nerds who go home in the evening and write like video compression codecs in their spare time. So what we do is try and create kind of prototypes for new audience experiences to BBC News and tools to help our journalists kind of do their jobs better. And at the moment, we're focusing quite a lot on tools that around editing kind of video and audio. And one common thing that we noticed across a couple of these tools is that we're using draft.js. So draft.js is Facebook's rich text editing framework based on React. So they created it to implement text fields on Facebook, and then they open sourced it last year. So in this talk, we're going to spend some time looking at draft.js, what it is, how it works, and how you can use it. And then we're going to talk about how we're specifically using it in some of our projects. So, text editor, and then you can kind of build up on top of that to make it more complex and have more functionality. However, I mean, it's been around for a number of years. Lots of people have used it, but it's notoriously tricky to work with. There's lots of cross-browser applicability issues, and you can't really be sure about the state of what is inside the element across different platforms. So Facebook can basically kind of crack that nut by wrapping it inside a React control component, and that kind of makes the state very flexible. And you can kind of reason about it and operate on it in a really nice way. So what does that actually look like in practice? So it's a bit more than just a kind of control component. There's quite a lot that it gives you to play with. So we're going to kind of try and explain a bit of that. So starting with kind of state. So I mentioned that it, as a control component, it manages your state. So it breaks that into two: the content state, which is actually the content that's being represented in your editor, and then the selection state, which is basically the user's cursor, or if they kind of click and drag and select some text. So I've got a demo to show that off. So here's a really simple draft.js text editor component. So this is just a kind of a div, and you can jump in and start editing this content. Click around, delete stuff. So what is going on here? Bring up the dev tools. So hooked into the component did update
React component lifecycle methods. So if I then click back into the editor, that breakpoint has been hit. So what's going on? We can see that in our state, we've got an editor state, and that is an immutable record. So draft.js uses immutable records to represent basically all the different things going on in the state, and there's a whole kind of hierarchy of those. And there are methods on that we can use to pull out the content state and the selection state. So if I click through that, and then go in here, you can see each time I'm kind of clicking and moving the cursor, that's causing the selection state to change. Similarly, selecting ranges does the same thing. And then typing causes the content state to change. And obviously when you type, the cursor moves, so that changes the selection state as well. So what is actually going on kind of inside the selection state? Let's take a look. So updated the demo. Got a console log statement that's pulling some values out of the selection state. So we've got basically the start and the end of the selection. So the start's in blue on the left, and the end is in red on the right. And if you go around moving the selection, you can see that the first value in each of those is the offset. So moving to the left, it's kind of going up by 1 each time. And again, because the selection is collapsed, we haven't selected range, those are the same. So if I start selecting range, the start stays the same, and the end goes up. The second in each of those is a reference to the block. So in draft.js, kind of paragraphs of text, if you will, are represented by blocks, and each block has a kind of unique key that you can use to address it. So that's what's being printed out. So if I move down, you can see that the second value has changed, and you can select across blocks as you might expect. So what have we got there? So now we know that we've got a content state made up of blocks and a selection state that gives you the offset and the block key of the start and the end of the selection. So we've got the tools to kind of address our content and address ranges within it. So now Rob is going to talk to you about what kinds of things you can do with those. Hello, can you hear me? Yeah, great. Okie dokie. So. Yeah, so we basically got the ability to address text inside this big block. And let's just look at a couple of use cases that you might be familiar with. So I take this word here, obviously making that selection, and I can apply what is called an inline style in draft. So what that is exactly what it says. That's an inline style. So I've made that the background color of that green. So if I find that div, that span, there it is. And I can kind of rinse and repeat this and highlight a few words in my text. Now that's pretty cosmetic, and that's sort of kind of obviously what you use it for. But I might want to do something a little bit more funky. So let's say, for argument's sake, I wanted to represent these words as companies, and I might want to add a stock ticker to that to sort of tell me what the current stock price is of Facebook. So there's another mechanism which is very similar, which allows me to highlight Facebook again. In this case, I'm going to basically tell sort of this world, if you like, that is actually a stock with a price. And then if I hover over that, you should, I don't know if you can see that, but there's a stock price there with a ticker. So these things look quite similar, but they're actually fairly different in draft. And they're known as styles, inline styles, and entities. So what draft is doing under the hood is taking all of those characters and it's putting them into a list. So you can see there that I've got Facebook
is set, and it goes all the way through to the end of the block. Up here, I've got my style, which says that my particular style in this case is I want to make that background color green, but I could obviously add a few more styles there, like make it bold and all that sort of stuff. So what draft is doing is basically mapping that style to those characters, and you can map more than one style to a character. If you imagine the WYSIWYG editor case where you've got a bold and italic at the same time, it's that sort of thing. And this is kind of what, as we saw, what gets rendered out. So there's those words with that style around it. Now, an entity, it's similar, but a little bit different, because I've got this kind of metadata that I want to associate with those groups of letters or that word. So I can create an entity and I can give it a type, and I can give it some data. And in the same way that draft will apply the style, if you like, to the characters, it applies the entity to those characters. So as a result, it knows how to render that. What I get is I get more information at the point I render, so I don't have to just apply a style. I can actually, I've got a little React component there, which I can pass that data from the entity in, and it obviously comes out, in our case, as a title. Now, there's a thing here called mutability, and the best way to represent this is that classic case in Facebook, where if you reference somebody and you sort of delete their second name, it's still an entity, it's still a link through to Alex, but I've shortened his name. And that's called segmented mutability. So I can kind of change the internals, and it won't delete it. But just missed it, actually. Just wait for that GIF to come back around. With BBC News, it's a page, so I don't really want to sort of change what that's called. So when I delete one character out of it, it will delete the whole thing. And that's called an immutable entity, which should. So, there we go. So we can kind of add these two sort of concepts to our chart here. So we've got entities and we've got character metadata. And this is basically what we can then do with the content state. And then there's a final piece of this, which is all about serialization. So kind of if you're doing stuff in the editor, you're mutating the state, but you kind of want to do something with that. You might want to save it to a database. You might want to kind of write it to HTML. So it's a piece of draft which allows you to serialize your state in various ways. So the default state kind of serialization is called the raw state, and it's like a JSON format, and it's that. So you might see some things you're familiar with inside here, like Facebook is out to roll out the app. So that's obviously my block text. And those keys that Alex mentioned earlier are in here. And if I add a highlight and resave, that highlight is then in here. And I can take this and stick it in a database somewhere, and then I can inject this back into my editor when my user loads the page, for example, when it kind of gets me back to that state. So that's called convert to raw, and it kind of works. That JSON format works for when you're kind of persisting it to a database, but you might want to kind of serialize it as another format. So Markdown or HTML, if I've kind of got a blog that I'm writing or something like that. Or, as we found, you might want to write your own serialization because your data format is not in that kind of vanilla kind of area. And we spent some time doing that in our projects. So that's sort of an overview of what draft is, and we can kind of talk you through now in the context of two projects we've been working on in labs. So Al, you're up.
Cool. So I'm going to tell you about a project that I've been working on. It's called Octo, or Online Content Toolkit, which is a really terrible name. So if you have a suggestion for a better one, please tell me. So what this is all about is the fact that as BBC News, we deal with huge amounts of audio and video content. So we have stuff being, many hours of stuff being produced in-house every day. We've got live feeds of events all over the world coming in from agencies and other broadcasters that we partner with. And we also have almost 100 years worth of archive content on a variety of different formats that's kind of gradually being digitized. And all of that is used every day to form our output. So traditionally, we obviously broadcast on TV and radio, and at this point, our website is probably quite traditional as well. But we're kind of increasingly trying to put our stuff onto other platforms. So primarily social media, Facebook, Twitter, Instagram. And there are obviously kind of considerations about creating content or putting content on those mediums that are kind of different to our traditional output formats. So Facebook
It's all about vertical video, Instagram it's square, so there's kind of aspect ratio stuff. And then the fact that many users aren't going to be having audio when they're looking at their Facebook feed, so they need some kind of like visual representation of the speech content in it for it to kind of get the message across. And we're quite interested in kind of analyzing the content that we're dealing with in order to build tools that let us kind of transform it in different ways appropriate for these different kind of output mediums. So there's a bunch of different kind of potential things that we're looking at that, you know, are variously kind of hot topics out there. We're primarily focusing on speech to text at the moment. So what does speech to text do for you? So say you have some video or audio content, running that through a speech to text engine takes the audio and tries to literally just identify the words that are being said in the speech. And what you get out of that is the words themselves that it's identified, but also quite rich data about the timings. So you get start and end times for each word. And those are quite accurate, so kind of often to the millisecond. We also get speaker information, so it will try to distinguish between kind of different voices in the speech and return that as well. So let's see how that is, if we can get some sound off the laptop. Perfect.
But even though Beijing hopes that her achievements will help convince many people here to have more.
So here's just a random kind of snippet of kind of BBC News video content that we pulled from the archive. On the right-hand side is the actual words that were spoken. Putting it through our kind of in-house speech-to-text engine, which usually works pretty well with BBC content. Like, it's done all right, but there's still a few mistakes. So the kind of completely wrong words are highlighted in red. It's talking about Hercules for some reason. It's got a lasting undermine instead of lasting on their minds. It's a bit, you know, it could be better. It's also not highlighted, kind of missed out some words, and the punctuation's a bit all over the place. So what we'd really like to be able to do is take this as a kind of starting point and then have some kind of interface that lets people correct the mistakes, but still maintains the really rich timing information. So that is what we have tried to build. And I'll show you that. So this has got audio as well. So this is a kind of text editor interface built on draft.js that lets you load up a transcript that's come out from the speech-to-text engine, and you can play through it along with the video, and it highlights the words. And you can just kind of go through quite naturally and correct those mistakes. There's some keyboard shortcuts, so you can do a kind of quite efficiently work through. And you can kind of see how it's, you know, in relatively little time you can work through and polish that up nicely. And in comparison to the kind of existing workflow for this, where you kind of start with nothing, some poor junior journalist would have to kind of sit down and transcribe it manually by hand, and then maybe hand that off to their producer, who would decide what they want to do with various bits of it and highlight it, and then they bring it back, and it's just a nightmare. So this really speeds things up. So what's nice about this is it behaves very much like any other text editor. Like, apart from the keyboard shortcuts to play and pause and skip the video, there's really no difference. So for a journalist who's used to using Microsoft Word in their day-to-day business, it's really easy for them to just pick up. So how does it work? So basically, in that editor interface on the right, every single word, everything that you can see is an entity. So as we know, you can associate entities with words and stick data onto entities. So every word in that transcript has a word entity, and that has the start and end time stored in the kind of data field. And then the spaces have entities as well, just so we can kind of address those as spaces rather than kind of like guessing that there's just some kind of blank block of text. So now that we've kind of like got this structure in the editor, we can think about how to handle the state when edits are made. So in kind of maintaining the timings, there's a kind of set of almost kind of heuristic rules that we need to apply that dictate what we should do when things like new characters are entered at the end of a word, or two words are stuck together, or the user presses enter and splits a block into two blocks. We need to make sure that kind of carries the speaker information through. And there's a whole bunch of these, and some of them are kind of more crucial than others, but they all kind of build up to create that experience. So let's take one of those and kind of look at how that translates into modifying the editor state. So this is where maybe the speech-to-text engine has identified two words when they're actually one, and the user deletes the space in between them. We need to kind of figure out what to do with that. So here's a kind of example of a passage of text from the editor. So there's four words and spaces in between them. The user's gone through and they've deleted that middle space. So now what we can do is look for instances of two different word entities next to each other, but without a space. So we can kind of iterate over that content and look for instances of that. And in that case, apply the same entity to all of that text and make sure that the kind of start and end times are updated as appropriate. So we've taken the end time from the second entity and the start time from the first and kind of glued them together. In code, it's pretty kind of self-explanatory. Basically just iterating over the list, making that check for two word entities next to each other that are different, and merging them together, and then sticking the new entity onto the list. So that was the kind of approach we took to the behavior of the editor. But then obviously once you've made all these edits and corrections, you wanna take those and kind of save them somewhere, and use, as I said, we want to use that for the basis of tools. So we decided to kind of implement a kind of common format to represent these transcripts. So we've got a transcript class, which is based on an immutable record. And by defining that, we were able to kind of pass that around our different tools. So you can kind of create an instance of a transcript class in the editor and then hand it over to another tool that understands that and can do other things with it. So there's a kind of journey to get from the editor content state. So you've got a method that converts that into a transcript class instance. And then for persisting to a database, we've also got a kind of JSON representation. So there's a method that converts into JSON. And we can go back the other way to populate an editor from JSON. So that is something that we think could be useful to other people who are also interested in kind of working with timeline transcripts and media analysis. So looking to open source that pretty soon. If anyone's got any thoughts about that, please get in touch or speak to me. So then, kind of like I keep saying that we want to use this as a basis to build tools. So what kind of tools might they be? So looking at kind of subclipping videos based on the transcript, and also generating subtitles or kind of captions on Facebook and Twitter and things like that is quite a big use case. So here's a kind of a taster of one of our other prototypes that consumes these transcripts and then lets you kind of manipulate media using them. So it's the same video, it's uncorrect transcripts, selecting a bit of it, turning on subtitles, and kind of instantly grabbed a bit of that video, generated subtitles, and then we could put that online. And that's a really kind of like snappy workflow for a journalist. And that is Octo. Now Rob's going to talk about doing the opposite thing. Right. Okay, yeah, so I've been working on a tool called Alto, which Al says does the exact opposite of what Octo does. So I think a good starting point is a bit of context. So I'm going to show you a video of a video, which is a bit weird, but you probably recognize this. This is a media asset page on the BBC News website. It's in the world service, it's in the Russian, but it's essentially the same code base as you're used to seeing when you're in the UK. And that's a video that was published last December, 21st of December, out into the Russian audience. And that was produced using Alto. Okay, so as I mentioned, that's a Russian world service media asset page. We got a massive world service in the BBC. We've got 29 services. Russian is just one of them. We're soon to have 40. But that video is atypical of a lot of world service content, which is that it was originally in English. You probably may have seen that video in the UK. And the Russian journalists have taken that and they've reversioned the audio track. And they've put it back out again for the Russian service. And how they traditionally do that is they do that in one of our studios. So they are going in with themselves or somebody else. So there are two voices in that video, recording the audio track, dubbing it basically, putting that back through all the BBC kind of systems and putting it out online. And what we've been exploring is trying to give them an alternative to that workflow. And that alternative is using a synthetic voice, which is the same technology which Siri uses to read you back the weather when you ask for it. So that video you heard before was a synthetic voice. So just going to show you a video now of how what is this tool and how does a journalist use it. So I've managed to find a pretty cool jazz video. So jazz. So this is a jazz video, right? There's no one in it. There's no one speaking in it. But this is what we call an oeuvre. So there's no actual presenter, but we want to give it a voice track. It doesn't have one at the moment. We want to overlay one. So this is the journalist doing that work. So on the left-hand side here, I've got my transcript. And this could well have been taken from Alex's tool. It wasn't, but it could well have been. And we're going to tidy that up a little bit. And of course, that's a draft.js editor there. And then what our journalists will do is they'll put that through Google Translate. Now, because I don't speak Russian, and probably a few people here do, but this is going to be in English. But normally that would go through Google Translate, and that text there would be in Russian. We also do this with Japanese as well. And depending on the service, like Google Translate for Russian is pretty good. We've been doing this for a year, and before they did the deep neural network stuff, it wasn't quite as good, but we've now found that that doesn't really need too many corrections. So I've got my translation. I'm going to give it a listen. I'm going to read.
The Nice Jazz Festival, held annually since 1948, was the first jazz festival of international significance.
So we've sent it off to our TTS service, and it's obviously read it back for us. And as a journalist, I might be interested to hear what those other ones sound like. So I can kind of have a little preview.
The Nice Jazz Festival, held annually.
Now, already, I'm thinking I want a bit of that jazz to come in a little bit later. So instead of that first block starting at 2 seconds, I'm going to start at 5, so we can hear a little bit more of that music. And I'm going to adjust the fade so we get a nice fade down. And I might also reduce the duct volume so that you can hear the text, so the balance is a little bit better. And then give that another listen.
The Nice Jazz Festival, held annually since 1948, was the first jazz festival of international significance at the inaugural festival.
So what's happened now is that second block's come in and it just doesn't sound very good. So we're going to kind of move that around, give that a bit of padding. So 2 seconds after the end of the first block there.
At the inaugural festival,
Sounds good.
Louis Armstrong and his All-Stars were the headliners over their years.
Same's happened again. This is called like the ripple effect. We spent some time because journalists notice they're always changing the blocks. So we've got a solution for that.
Over
Yeah,
the
have another
years,
listen.
many artists such as Dizzy Gillespie and Miles Davis regularly appeared at the festival.
So preview sounds quite good. Adjust my fade out so it sort of fades down nicely. I'm gonna mix that down. There it is. And then that is the video.
The Nice Jazz Festival,
There we go.
held annually since
So you kind of get
1948, was the first
you get the
jazz
picture.
festival.
So, cool. So that allows us to reversion things quite quickly. And how does it work? Well, it's all based on, a lot of the UI is based on draft.js because it's all about text editing. But what we kind of do with that is we're sending off some information to our text-to-speech API so that it can read it back. So I'm telling a text-to-speech API that I want you to read this in hue, and that there's the text I want you to read. And all it does is send me back an audio file. It's pretty quick. A piece of text that long would normally take between 1 and 2 seconds. And then we use a combination of the web audio API in the browser and FFmpeg to kind of basically put that back into the video, mix that down. And we use the web audio API to give the user a really quick feedback loop. Now, this technology is good, but it's sort of not all voices are created equal. And the interesting thing with these voices is that they are all once people. So what's happened is Hugh and Fiona have gone into a recording studio, they have spoken a script, and then that voice has been modeled, and then we can make it say whatever we want. But I'm going to give you an example as to why, as some of the complexities of dealing with this technology.
Festival, held annually since 1948.
So Hugh is absolutely fine pronouncing that word Nice.
The Nice Jazz Festival.
But Fiona was not that good at doing it. Now, there is a very lean MVP way of solving that problem, which is to do this.
The Nice Jazz Festival, held annually since 1948.
And that's what our journalists were doing for a while. They didn't even tell us. They were just like, well, we've had to like respell stuff because it doesn't always sound right. And because you can see that, it's like, depending on the voice, it's not always the same. So we were running with that for a while, but what the problem is that, as you can see in the middle there, that is, as one of Alex's timeline transcripts, we actually want to use that to generate subtitles. So we can't have a journalist kind of littering it with spelling mistake because we want to show that on screen later. So I was rubbing my hands together because I had a nice feature to work on, which was we kind of need a way to pronounce words specifically for a voice and keep the original. And because it's quite time consuming, it is quite fiddly to get the pronunciation right for some words. We wanted to save that so that as soon as somebody's corrected Nice, no one has to do it again. So going back to how this thing works, on the right-hand side, our sort of API, it's a solved problem. We don't actually give it text. We give it something called SSML, which is an XML format, which kind of defines how the engine should read the text back. And that's got a bit in the spec, which is called the sub element. And if you can see there, I don't know if it's clear, but I've given it W3C, but I want it to read World Wide Web Consortium. So the theory was, oh, fantastic. We've got the Nice Jazz Festival, and I can kind of make it say it in a different way, but obviously I keep my spelling of Nice. But the challenge was kind of, what's the user experience? Oh, hang on, I've got a bit of a typo there. And that is the user experience. So this is all about text editing. We wanted that user experience to be as familiar as a user normally would be. So we kind of chose that sort of spelling check paradigm as what we're going to go for. So this is what we built.
The Nice Jazz Festival.
So what I can do is I can select my word, and I can, oh, sorry.
The Nice Jazz Festival.
I can select my word, and I can hear that in isolation.
Nice.
Nice. I can do my correction.
Nice.
And then save that, so everybody else gets it. we get a nice little underline.
The Nice Jazz Festival,
And there it is.
annually since 1948, was
I actually realised it's the opposite of a spell check because it's correct, but anyway. So, enter draft. Before that feature came on, we were just using content editable because we didn't really have requirements or anything else, but draft kind of made this feature doable, really. So the theory is, I've got my Nice Jazz Festival top left-hand corner. We know we've got these things called entities, which allow us to apply metadata to some text. And what I want to come out the bottom is that bit of XML, which has got nice and nice in it. So from a user's perspective, what are the hooks? Well, you saw that first one. I'm creating a new one. So I create my nice and I press save and it gets applied. Also have a hook, which is that when I change the voice back to Hugh, I don't want that to be there anymore because it's not a pronunciation that Hugh needs. But these are like nice reactive hooks, like they're just props that we're passing in. But because we want this to be a nice user experience and text editing-like, we also want to kind of apply these pronunciations as the user's typing. So we've got some draft hooks that we're also using, which allow us to hook into typing characters forward and deleting characters. So just look at a simple use case. I've got this as my text, and I'm actually doing it. It's not quite what you saw, but I've got a pronunciation in my dictionary of Nice, and I'm about to write the word Nice again. So you can see it on the left-hand side, we've got one already. So I enter the letter E, and this is the state. And then what we want the state to be is that I want that entity two entities to exist in that text. So the first thing I need is to search. I need to search that body of text for something. And what I'm looking for is all the saved pronunciations that I had before. So in our database, our API exposes our pronunciation. So I've got the original, I've got the alias, and I've got an ID. And we run those two things through like a regex, which was more complicated than I thought it would be, because UTF-8 and like Cyrillic, and the UTF-8 part was the bit that kind of got me going. But basically, at the other end of that, we get our search results. And what that says is that pronunciation at the bottom should appear twice in this text, and it gives me the start and the endpoints. So coming back to our use case here, where my editor state is like this, I've just typed the letter E. I've got my search results, which should be in there. I can then use an entity range. I can find the entity ranges, which is part of draft, which allows me to look for entities within this body of text. And it tells me that you've got one already. You've got one at the start of 5 and 9. So that's obviously that one on the left. So obviously you've got a gap. So it's very clear to me at this point what I've got to do. I've got to create one, and I've got to apply it to that position. And obviously, of course, as a result, I get that. So just looking at this entity a little bit, all entities have a type. I've got a type pronunciation. The data that I need to do this is the ID of the pronunciation that I had pulled down from the database. That allows me to actually update ones that have changed. And of course, I've got the alias. And then I need the mutability to be mutable so that we can delete characters and come backwards and forwards like that. I don't want that whole word Nice to be deleted. So this is what we built. We built a draft plugin. It's got these components, which hopefully, from what I've just explained, you can see how they all fit together. And something I didn't mention is this whole thing about updating. We don't want to create an entity, loads of entities every time we do this. So we're checking that we don't recreate entities that already exist. And so that update was actually quite an important feature of this. But of course, so what I've now got is I've got my editor with my orange lines in it, but I need to then send that to my TTS. So that's where the serialization comes in. And basically, with the serialization with draft, you want to kind of keep that to the outside of your application because it's quite expensive. So I didn't want to do it on every keystroke, for example. So the best place for me to do that is when the user presses play. So what we've got is we've got like an SSML serializer, which takes that content state in and transforms it into XML. And at that point, it's pretty simple. I've got my entity, which I can access my data, which is my alias there, and I've got my text, which draft is giving me outside of that. And there we go. That's the XML which we are able to send up to the voice provider, and that is what makes it read correctly. So I think that's pretty much it from Alto. We kind of hope that that was a useful overview, and we tried to dive a little bit into some of the details because some of this stuff was absolutely key for us. We've obviously gone to town on entities, and we wouldn't have been able to do, both our applications wouldn't have really been able to sort of work without those. Al, have you got anything you wanted to add on the content state?
So content state, we found that having a really kind of well-defined and predictable content state that you kind of reason about kind of from what it is originally to what you want it to be, you can kind of write these really nice kind of deterministic operations that transform it in that way. And then, yeah, same with serialization. We found that kind of really understanding the draft model and the kind of domain that you're operating in, let you kind of serialize it in a format that is most useful.
Yeah.
So thanks. There's some really good resources out there. The official docs are pretty good, like quite concise but reliable. Awesome draft.js is a kind of list of other resources, so that's a good place to land, and then that'll point you off in all kinds of directions for other stuff. There's an official Slack channel, and then there's some plugins that have been written to let you do kind of common use cases like the Facebook mention, kind of name mentions, for example. So those are worth checking out. And get in touch with any questions, comments, whatever. And BBC News is hiring. Do that for now.
Great. Yeah.
Do we have any questions for the duo? Go ahead.
Hi. Have you been able to work with large files, long text, and how does it perform when you apply entities to each of the words in long text?
We haven't particularly, in the transcript editing use case at least, we haven't particularly kind of stress tested it. Yeah, initial indications seem to be that Draft is pretty good at handling a lot of data. Like they're good, like the way that they've designed it is pretty efficient, and the whole using immutable records for managing the state seems to be a good way to go. So got kind of good vibes about that, but no actual proof. Yeah.
Hi, thanks very much. I was just wondering, are you maintaining the speech-to-text APIs internally, or are they external services you're rolling out to?
Yeah, great question. So they're currently external. So we've got 2 suppliers that we use to give us a mix of the voices. But we've got a project in labs to investigate how we can. We've got a problem at the BBC. We've got lots of niche services that the commercial TTS providers don't supply voices for because it's not in their interest. Well, it probably is, but it's prohibitively expensive for us to pay them to make us a voice because we need at least 2, because we need a male and a female. So we've got some work we're doing with some research work to understand how the sort of ways in which we could build our own voices.
So the speech-to-text, we've got our own engine internally, but that's based on a kind of open source kind of framework for building speech-to-text engines called Caldi. And then a team in the BBC have taken that framework and kind of created an implementation of it that is trained on BBC content. So they fed it a whole bunch of BBC TV and radio content, and that's created a model. And then that we found performs pretty well when we feed it more BBC content, as you might expect, kind of better than commercial providers like IBM. Yeah.
Just 2 questions. I know from my experience working with WYSIWYG editors, and I don't know if you have this problem, when I did a long time ago, there was always that thing, they wanted to be able to paste from Word into the editor and keep the formatting. I don't know if that's something you have to worry about because it's just text. The other question was, with the thing where you're going back and you edit nice and you make it to just NIC and you keep that as mutable, what happens if they start typing into another word that is also like got a pronunciation for it? How does it know to remove that kind of entity from that thing?
Yeah, so on the pasting, so draft.js has a kind of built-in helper method that lets you convert from, it kind of does its best guess at converting from HTML to the kind of editor's state. And I believe what happens when you kind of copy and paste some rich text with bold and colors and whatever, that kind of gets copied as HTML. So then it will take that and do its best job at creating an editor state from that. I think in both of our use cases, we wouldn't want anyone to be able to do that because we don't have any kind of concept of what like bold means. So you can hook into the kind of on paste method and either kind of transform what is pasted to just be plain text or prevent the user from pasting entirely. To answer your second question, yeah, it's quite robust actually. So if the search term is not in there, it will not find it. It's quite kind of intense way of doing it. But if you take that example and you have nice and you've deleted e, there's no entity anymore. If I then take that back, there's still no entity. So it kind of does work reasonably well. It's quite robust, but yeah, once your dictionary gets quite large, you might have problems. Yeah, but we don't have them yet.
Hi, great talk. I was just wondering if with that data that you have for corrections, so you're actually obviously tracking a lot of data for corrections to audio. So someone's obviously, in fact, in both of your examples, one where they have something like nice and they are kind of annotating that and saying, I want that to be pronounced as nice. And also in the case where you have the speech and turning that into subtitles, that seems like pretty valuable data for things like machine learning applications. I was just wondering if there's any intention or if there's any way that you're currently outsourcing that data or making it available to people who might want to use it for machine learning.
So on the speech to text side, that is something that we're certainly really interested in. With our current kind of engine and its model specifically, the training process for that is super intensive. It's more a case of like assembling your training data and then setting the process running on a bunch of like really hefty GPUs, spec'd out machines for 3 weeks, and then you come back and you've got a model. So we can't really do that iterative, but we have seen like there are other engines out there or kind of other systems for this out there that do let you do that kind of iteration and feed into it. And yeah, about providing that, I know that we've worked with at least kind of research organizations in the past to provide them with BBC kind of content and data for trading purposes. So I don't see why that wouldn't happen again. Yeah. Same.
Thanks.
Hey, thanks guys, that was a great talk. I wondered if you'd had any experience working with like kind of legacy databases. So maybe you've had a WYSIWYG editor in the past, which has output a lot of HTML with a lot of random rules, you know, with like inline styles and stuff. How customizable have you found draft.js for converting stuff from, you know, like HTML with a ton of kind of random rules in it? Is it easy to kind of iterate over that? And
it kind of does its best, doesn't it? Because you can load it with HTML.
Yeah.
There is an import from HTML, which I guess would do its best to sort out what's going on.
Okay. Okay.
Presumably it would strip styles and create inline styles for you, and you'd have that.
Yeah.
Yeah, I imagine that is probably quite a fiddly thing. You got? Yeah. I just say in terms of if you've got some format that's really funky, like as long as you have some process that can take that and kind of interpret it, you can then always construct the editor state. So you can say, you know, I've got these blocks, and each of those consists of, you know, this text with this metadata. So as long as you have some external process that can understand it, it's really easy to kind of create the draft internals that can then power your editor.
Okay. So is there a way of like writing those rules within, the conversion process as you input text HTML in?
I think for the most part, you have to handle that yourself.
Okay, yeah. Okay. Thanks. Yeah, it was really interesting.
Any more? Oh, over here.
Thanks. It's really interesting. I was looking at it, and it seems to be on and off, especially with the autocorrect. So what if somebody says it's nice in Nice?
Yeah.
How do you make one say nice and one say Nice?
Yeah, it's a good question. Yeah, sorry, I was just doing that. You might not bother.
Okay.
Yeah, truth be told. So, sorry, no, there is a good answer to that. Oh, there is a good answer to that. So, before we did the global dictionary, we had private dictionaries as well. Okay. So you can make your own pronunciation specifically for that word in that text, in the context of that project, actually in the context of the block. So that would solve that problem. Yeah, sorry.
Thanks. Cool. Anyone? I think we have to call it time there. Thank you, guys.
Brilliant. Good work, mate. Got there.
So a few more notices. So the React London conference is on the 28th. So get your tickets. It's going to be really good. There's going to be no meetup next month, but we're back in April. So if you would like to, suggest a talk that you want to give, then go to the website, which is meetup.react.london. And you can put your submissions there, and also Red Badger's hiring as always. Yeah, so thanks for coming. Join us at the pub across the road if you want another pint. Otherwise, see you next time. Thanks.